Remember that day back in October when a huge chunk of the internet just stopped working? One minute you're using your favorite apps, the next, they're just gone. Well, what actually happened? Today, we're going to pull back the curtain and dissect the massive AWS outage that was behind it all. Let's dive in.
I mean, think about it. We all lean on the cloud for pretty much everything. So what happens when the biggest cloud provider on the entire planet has a really bad day? As we all found out, the answer is, well, it's chaos.
And we're not talking about a minor hiccup here. The official report from AWS confirmed that a whopping 142 of their services were hit. Some were just struggling, others were completely knocked offline. This wasn't just a crack in the foundation. It was like a chasm opened up right in the middle of the digital world.
Okay, so to understand what went wrong, we first have to figure out where it all went wrong. Our investigation has to start at the digital epicenter of this whole earthquake.
And here it is, US East 1, located in Northern Virginia. Now, this isn't just any old data center. It is the original, the biggest, and you could easily argue it's the single most important region in the entire AWS global network. People literally call it the center of the internet for a reason.
To put that into perspective, just look at the sheer amount of data flowing through this one place. It's estimated that somewhere around 35 to 40% of all global AWS traffic runs through US East 1. So yeah, when this one region has a problem, it isn't a local issue, it's a global catastrophe, and it shines a massive spotlight on a potentially huge weak point.
In every major failure, there's a starting point, right? There's always that first domino that gets knocked over and starts the whole chain reaction. And in this case, the investigation pretty quickly pointed to one absolutely critical service, a database called DynamoDB.
Now, you might not have ever used DynamoDB directly yourself, but believe me, AWS uses it for everything. It's a foundational, internal service that they use to run so many of their other big-name services. The best analogy really is to think of it as the cloud's central nervous system. It's quietly in the background, controlling countless other vital functions.
And that's exactly why its failure was so catastrophic. So many other systems completely depend on it to function. The services that handle your logins, the ones that run your serverless code, the ones managing APIs, they all need DynamoDB to work. So when it went dark, it dragged all of these other critical systems down into the darkness with it.
So what actually caused it? Well, the root cause was surprisingly simple and yet absolutely devastating. An internal monitoring tool at AWS just malfunctioned. It started reporting that perfectly healthy DynamoDB systems were unhealthy, and that bad information got fed to the Internet's address book, DNS, which then did its job and stopped sending traffic there, effectively taking a healthy service completely offline.
Okay, so you just fix the DNS problem and everything comes back online, right? Well, wrong. By that point, the failure of that one core system had already kicked off this incredibly complex and destructive chain reaction.
If you look at the official timeline from AWS, it's just wild. They identified and fixed that initial DNS issue by about 2:30 in the morning. But that was just the beginning. Other systems already under stress started to fail, like the network load balancers. It basically turned into this high-stakes game of whack-a-mole for the engineers that went on for almost 15 hours.
So let's break down that domino effect. First, the address book for DynamoDB breaks. Because of that, new servers on EC2 can't start up because they can't get the info they need. All that strain then cascades over to the network's traffic cops, the load balancers, which then start failing their own health checks, leading to this massive widespread connectivity failure.
Now here's a really interesting part. Even after the AWS engineers started to get a handle on those core problems, for many of us, the outage felt like it dragged on for much, much longer. And that's because a secondary effect kicked in that was, in its own way, just as damaging as the first failure.
It's something called a retry storm. Just try to picture it. Every automated system, every piece of software, and every single one of us getting frustrated and hitting refresh over and over and over again. All of those millions upon millions of failed requests created a tidal wave of traffic that just hammered the AWS systems right as they were trying to recover. And the aftermath of that storm was just messy. Those bad DNS addresses got stuck in caching systems all over the internet, which made the problem last longer for some people. To get control back, AWS actually had to throttle or intentionally slow down their own services. And even after a system was marked as fixed, it still had this massive backlog of work that had queued up, which took hours to process. So, wow,
What can we possibly learn from all of this? This whole event gives us some really critical lessons, especially for anyone who's building an app or running a business that relies on the cloud.
The biggest takeaway really comes down to how you plan for disasters. Most people use what's called a multi-AZ or multi-availability zone setup. That's great for protecting you if one single data center fails. But this outage was different. It took down an entire region. The only thing that would have protected you was a multi-region architecture. And that is a whole other level of expensive and complex to set up. It's a really tough trade-off. Do you pay for ultimate resilience, or do you save on cost?
So, should everyone just switch to multi-region? Not so fast. As one expert pointed out, these kinds of massive, region-wide outages are incredibly rare. You really have to weigh the huge ongoing cost of running in multiple regions against the potential financial hit from an outage that might only happen once every 5 years.
But what about when AWS does fail? What's their promise to customers? Well, that's where something called the Service Level Agreement, or SLA, comes in. For a service as critical as DynamoDB, AWS promises an incredible 99.99% uptime. That's 4 nines of reliability. And when they don't meet that promise, customers are entitled to a service credit. Since this outage lasted for a couple of hours, it means businesses that use a lot of DynamoDB were probably eligible for a 10% credit on their bill. It's something, but it's a pretty small compensation for such a massive headache.
And all of this leaves us with one final, really important question to think about. The cloud has made things possible that we couldn't have dreamed of just a decade ago, but we're centralizing all of that power into the hands of just a few massive companies in a few key physical locations like US East 1. So, as we build this more powerful internet, are we also maybe building a more fragile one? That's the big question for our digital future. Thanks for joining me for this explainer.